Hello everyone, my name is Khushbu Mehta and I am a third year BTech CSE student at Manav Rachna University. So, today I have participated in Altair Global Student Contest. I have tried building an AI powered analysis and prediction system titled How Weather Conditions Affect PM 2.5 pollution in Delhi. So, in this project combines data analytics, visual insights, and machine learning using AI Studio to solve real and some critical environment pollutions which are becoming a mess nowadays, as we all know. So, my use case and motivation for it are Delhi is one of the most world's polluted cities, not only in India but all across the world. So, people and policymakers need a simple data driven system to understand how weather influences pollution, how pollution is likely to spike, and how to prepare for hazardous days because it is necessary, it is a necessity. So, my use case focuses on pollution forecasting so that both citizens and authorities can make informed decisions timely. Now, I would like to give my solution overview. But to what problem? To the question that can weather conditions alone help predict PM 2.5 levels? Yes. So, let us see how. My solution is a complete end-to-end AI workflow created in Altair AI Studio. It integrates multiple datasets, performs visual analytics, and builds a prediction model using linear regression. So my system includes it merges pollution and climate data, identifies meaningful patterns, shows relationship using scatter plots, predicts PM 2.5 levels using weather, and at most accuracy, it evaluates RMSE. Okay, so now let's start. Firstly, I have taken two data sets that are namely city cityday.csv and daily Delhi climate. They are I have used cityday.csv for daily PM 2.5 data, and I have used Delhi climate data for mean temperature, mainly for mean temperature, humidity, wind speed, and mean pressures. Now, I have merged both of them. I have merged both of them using the data column, which is common among them. So, the final features included mean temperature, humidity, wind speed, mean pressure, PM 2.5, which is the target mainly, and the date. Now, I will explain firstly. I will start using the pipeline explanation. I have used from the operators. I have used retrieve for loading both the datasets, city day datasets and daily Delhi city dataset. Then I have used a join operator which has merged both of them on the date column. The next I have applied is a the next I have applied is a replace missing values operator. Now the function of this is to handle null values, so it can fit the average values in the places of null values, making the whole graph consistent. Now after this I have it connected it with select attributes operator. Now select attributes is for feature, it keeps only features which influence PM 2.5 only. I have some special attributes, not all. Okay, and some of the special attributes which I have set are humidity, mean pressure, mean temperature, PM 2.5, and wind speed. Now, let's move on to the set rule. Set rule I have used to put the attribute, which is the main attribute, that is PM 2.5 as the label for prediction. Now, next operator I have used is split data, which is used as a 70-30 train test split to ensure reliable evaluation. Now it has been connected to two of the operators. First is the linear regression. Linear regression is trained used for training the prediction model and generate feature coefficients, which will help us further in prediction. The apply model and performances operator, they both work together, like predicted on test data and evaluated accuracy using RMSE. Now, RMSE means root mean squared error, which is 63.98. We will discuss later. Now, I will give the visualization insights, that is the scatter plots and the heat maps which I have generated using this pipeline structure. So I have taken earlier the photos of this so that we don't take much time in the explanation. So some of the graphs are the scatter plots graph which are in comparison with PM 2.5. For example, PM 2.5 in comparison to mean pressure, weak but noticeable. Then PM 2.5 in comparison to wind speed, strong negative correlation we can clearly see. Then PM 2.5 in comparison to humidity, slightly positive influence as we can already see. And the last graph is the tree map of PM 2.5, which is a straight line going negative. Now, so this through these graphs, we can conclude that PM 2.5 spikes in winter and dips during summer and monsoon. Now, model findings. My linear regression model. My linear regression model from stable, we can see that for every 1 degree rise in temperature, PM 2.5 falls 7.5 units. And for every 1 meter per second rise in wind speed, PM 2.5 drops 5.4 units. Now, humidity have smaller effects or we can say very less. Now, the model performance. The overall model performance I would like to discuss is the model achieved an RMSE of 63.98, which is reasonable given the high variability of Delhi pollution. Weather alone cannot predict every spike, but this model provides a data-driven baseline for pollution forecasting. So, in the conclusion, I would like to say my AI workflow successfully shows how climate factors shape Delhi's PM 2.5 pollution and provides a predictive model for estimating pollution levels using weather inputs. So, my system can support early warning alerts and also future predictive models. Thank you.